Hello students, so welcome back to the channel. In this video, we are going to study about water potential. Now see beta, try to understand what do you mean by the term water potential. Just take one glass of the water. Just imagine this is one I'm taking glass of water in which these water molecules, they are having their maximum free energy. Means they are having the maximum kinetic energy and they are in the random motion. They can move here and there very freely. Okay, so this water will have maximum energy, and this maximum energy we call it as water potential. Okay, so pure water has maximum water potential, and we assume for our calculation we will assume the water potential value of the pure water to be 0. Is it clear, beta? So when the water is there, only pure water, it is having a maximum kinetic energy, and maximum kinetic energy for the pure water is assumed to be 0. Now see beta, water molecule possess kinetic energy. This only I try to explain you. And in liquid phase and gaseous form, they are in random motion. They'll be moving here and there, both rapid as well as they are constantly moving. It means the more concentration, if the concentration of the water molecule is more, the greater will be the kinetic energy. And the kinetic energy means water potential. So now it means pure water will have the greatest water potential. So it is obvious that the pure water will have the greatest water potential. Clear, beta? So for convention, we have taken the water potential of pure water at a standard temperature, which is not under any pressure. We are taking it as 0. So that only I try to explain you. The water potential of pure water is considered to be 0. And how will you represent it? The water potential is denoted by a Greek symbol psi and is expressed in a pressure unit such as Pascal. So I hope so up till here you are able to understand the concept. Now see, when you are adding solute, now let us assume this is a beaker in which I have added solute. So these are my 5 solute molecules. I'm drawing it. Please try to focus. These 5 solute molecules I'm drawing it. So these solute molecules which are hydrophilic will be holding the water molecule. They are not allowing water molecules to move freely. So hydrophilic molecules are attaching with the water molecules, making the water molecule free energy available very less. Remaining are there, but if you see, only few water molecules are having the free energy. Other water molecules are bound. So we will say when the solute concentration increase, when solute concentration is increasing, you will say its free energy of water means water potential will decrease. Clear, beta? Free energy of water is decreasing. Let me take another example. Try to focus, beta, once again. Instead of 5 molecules, let me draw 8 molecules. These are your 8 solute molecules, and solute molecules are holding the water molecules. They are not allowing, these water molecules cannot move because they are attached with the solute. So very less free water molecules will be left for the movement. So now I'm drawing it separately. That is only the one which is left for the movement. So as a result, when you increase the solute concentration, you're finding free energy of the water is decreasing. Means water potential is decreasing. And how much proportion it is decreasing? It is decreasing with respect to the solute. So once again, please focus, beta, we'll write it. Solute concentration increase, then water potential value decrease. And solute potential also decrease. So from this we can conclude, the water potential is equal to the solute potential. Okay, beta, we can conclude yes, water potential is equal to the solute potential. Let me show you the NCERT. Now see beta, if some solute is dissolved in pure water, the solution has very few free water molecules. Very less water molecules are left free. Okay, and the concentration means free energy of water is decreasing. As a result, we will say its water potential is decreasing. So when solute concentration is increasing, water potential value is decreasing. Hence, all solution has a low water potential as compared to pure water. And the magnitude of this loading, how much loading will be done because of the dissolution of the solute, is known as solute potential. And solute potential is always negative. Please focus, but a solute potential is always negative. It means more the solute you are adding, more negative potential is the solute. So for a solution at atmospheric pressure, if you take a solution at atmospheric pressure, what you will find, water potential value is equal to the solute potential. So I hope so up till here, this paragraph, each and every line is clear to you, beta. Now see, beta, there are two solutions I have taken. A beaker, A side, and please focus on the B side. If you see on the B side, you are finding solute concentration is high. Okay, so you will say here, solute concentration is high. And if you see in the B side, here very few water molecules are available for movement. So free energy of water is decreasing. It means water potential value is decreasing. Here, if you will say solute concentration is less as compared to B. Here, solute concentration is less as compared to B. So here we will find free energy of water is high as compared to B, okay? It is always compared to B, I'm right now explaining you. So we will say water potential value is high. So from this diagram, you are able to get an idea that A is having high water potential. Here you will say it is having high water potential, and here you will say it is low water potential. Water will move from where the free energy is high to the where free energy is low. It means water will move from here to here. Water movement will be from here to here. Is it clear, beta? So water will move from high water potential to low water potential. Means it will move where the free energy of water is high to where the free energy of water is low. Let me show you the NCERT. Now see beta, if two systems containing water are in contact, random movement of water molecule will result in the net movement of water molecule from the system where the water molecule will move. Movement of water will be there from the system with high energy to the one with the low energy. Means water will move from the system which contain water at high water potential to the system which is having low water potential. Is it clear? And if you see right now, the substance are moving from high free energy to low free energy. This is known as diffusion. So this process of movement of substance down a gradient of free energy is called diffusion. So I think so that diagram which I've explained you, if you apply this diagram, this diagram to this theory, I hope that this topic will be clear to you. So up till here, we have understood that pure water is having maximum water potential, maximum is 0. When you add solute, water potential value decreases. If you take two solution, if you are taking two solution, water will move from its high water potential to its low water potential. Clear, beta? Now see, we are taking a cell and we are now putting it into the beaker which contain water. Here water is there and this is pure water. The pure water, you know, it is having maximum water potential 0. And this is your sap vacuole. Okay, beta. So the sap vacuole means it is having water plus mineral. The sap vacuole value will always be in the minus. So water potential of the said vacuole will be in the negative. Now, as a result, what will happen? Water will enter inside. Water will start entering inside. Endo-osmosis concept will be going on because water, as a rule, you know, it will move from high water potential to low water potential. When the water is entering inside, then the pressure is increasing. And the pressure is applied, this pressure, because of the entry of water, pressure which is applied on the tonoplast is applying on the cytoplasm, which will apply the pressure on the cell membrane, and it will apply on the cell wall. So this pressure which is built from inside to outside, this pressure is known as Turgor pressure. Turgor pressure, which is also known as pressure potential. So if you see better, before I kept it in the beaker, before we kept it in the beaker of the water, let us assume water potential value was -5. Solute was -5, that is a reason. And there was no pressure, pressure was 0. When the water entering inside, the pressure started increasing. Okay, beta, the pressure is increasing from +1 to +2 to +3 to +4 to +5. This is the way pressure is increasing. And we are finding when the pressure potential increases, water potential value is also increasing. Water potential value is also increasing. Please focus the diagram carefully. You will understand the concept. So when the pressure potential is increasing, we are finding water potential is also increasing. Clear, beta? When this increase, even water potential also increase. So when you apply pressure on a solution, you're finding pressure is increasing, water potential value is also increasing, and finally the stage comes. A stage comes when the cell becomes turgid. Okay, before that, when we kept in the beaker, that time the cell was flaccid condition. It was in the flaccid condition. And because of endo-osmosis, pressure is increased, water potential value is also increasing. So from this, we can conclude that water potential not only depend upon solute potential, it also depend upon the pressure potential. Is it clear? It means water potential not only depend upon solute potential, it also depend upon pressure potential. So see beta, if pressure greater than the atmospheric pressure is applied to pure water or solution, its water potential value also increase. You can see a pressure can build up in a plant cell when water enters a plant cell because of the diffusion. And the pressure which is built up against the cell wall, that is known as Turgor pressure, making the cell turgid. And this is known as pressure potential. So pressure potential is usually positive. Pressure potential is usually positive. Why we are saying usually? Because in one cases we'll be studying it negative also. And pressure potential is denoted by the symbol psi p. So it means we can say that water potential of a cell is affected by two, that is solute potential and pressure potential, and this is the way we will represent this value. So I hope so in this video today we have understood what is water potential, how it is controlled by the solute potential, and it is regulated by pressure potential also. Thanks for watching.